Okay, so good afternoon, everyone. And my name is Michel Bartman. I'm the OTF moderator. I'll be helping Peter and Grant today. I just want to welcome you to this new OTF Connects presentation titled Addressing the Data Analysis Expectations Using Google Colab to Analyze and Graph Your Data. And as I said, we have Peter Beans and Grant Hutchison with us today. We are very fortunate to have Peter and Grant with us. This is already the third episode in our series of 6 coding webinars. We were just mentioning that we had noticed a few familiar names in the list of participants. It's always great to have return participants. It makes us happy. And for those of you who are new with us at OTF Connects, we just want to welcome you for this presentation. Before I start, I want to quickly read a land acknowledgement that OTF is asking us to share with you. So we acknowledge that we are gathered in the territories of various indigenous people, and we further recognize their stewardship of these lands in which we live, learn, work, and play. And we have 2 presenters with us, so it's always great when we have 2 facilitators. It makes it a lot better in terms of following up with questions in the chat box and all of that. Peter Bean is a retired teacher who throughout his career has taught computer science, information technology, computer and communication technologies. He is also the past president of the Association for Computer Studies Educators and the chair of the OTF Curriculum Forum Steering Committee. Peter also worked with the Ministry of Education, having helped develop the current technological education and computer study curricula. He is a very versatile individual with interests as diverse as computing, programming, photography, playing the guitar, and long-distance motorcycling, amongst many other things. And Grant Hutchison is the second presenter. He's a computer science teacher at Riverdale Collegiate in Toronto and a senior a seasonal instructor with OISE. He is the current president of the Association of Computer Studies Educator of Ontario and frequently presents at educational conferences. Prior to teaching, he held various roles at IBM Canada. He graduated from Wilfrid Laurier and from the University of Waterloo. And when he's in teaching, he can be found on the ski hills or on the squash courts. And I actually found out that I have quite a few affinities with Peter and Grant because I myself am a photographer, and Peter and I chatted about that last time. And tennis and squash are my 2 favorite sports. So here you go. So what time is it? It's almost 4:05. And I'm going to now I'm going to stop sharing my screen. I'm going to invite Peter to share screen again, and we can start the presentation in a few seconds. So Peter, if you want to share your screen again. We have 23 participants in the room right now. I'm expecting a few more. So 57 registered. So we should hopefully reach about 30.
Well, welcome everyone. If you haven't filled in the survey yet, if you could please do that. Grant will drop the link into the chat window every few minutes. That survey you'll see is a Google form. And if you haven't used Google Forms before, that will populate a Google Sheet, which we in fact are going to use later on in the presentation. So it'll be kind of a full loop. We can see exactly how the survey results are going to be used. So I've got a few links and a hashtag for you. If you do decide to tweet during this, there's our hashtag OTF data analysis. The presentation link itself is right there. So it's bit.ly and then just OTF data analysis. And the repository, so this might be new to you. I'm using what's called a repository on a website called GitHub. And GitHub for computer scientists is pretty much the standard place where you would participate. In fact, if you're a computer scientist, one of the most important things on your resume is the address of your GitHub account. And it's no doubt that employers will look at your GitHub account and look at the amount of activity on it. They actually have a nice little graph showing how many times you've uploaded to your repository. And we'll have all the resources. So everything that is shared today, all the demonstrations that I do, some other notes are all there. So why this passion about data science now, about data analysis? Well, it's all over the place in the curriculum. And certainly it's been brought to the forefront this year with all the graphs we see with COVID-19. You know, you're seeing these graphs everywhere. And in fact, one of the first things that I did when I was learning how to do this was go out and find some COVID data and figure out how to plot it. So here's just sort of a map of, you know, many different subject areas that include data analysis in the descriptions. One of the big ones, of course, is elementary math. So data analysis and coding is a very big part of that now. And just searching for the word data. So I have one Adobe Acrobat file where I've taken all the subject areas and dumped them into one file and did a search. And you'll see that the word data appears 2,200 times across the curricula. So it's very popular across the curriculum. And here, of course, here's proof that in grade 8, analysis of data is right there. So if I go too fast, please let me know. Just drop a message in the chat, and then Grant, just yell at me. So the first thing I have to say, I am not an expert at this. I've been practicing with data analysis using these tools that I'm going to be showing you for a few months now, and every single day I'm learning new things. I've worked through probably 100 different models, things that I want to analyze, and I'm still learning, still looking things up. So I'm not an expert. I don't know if anyone will ever be an expert. It's further complicated because there's always more than one way of doing things, right? But I certainly will do my best. Second, I have to say, Stack Overflow, this is kind of a running joke with computer scientists, Stack Overflow is your friend. So if you ever get stuck, you just go to Google, just search for the key things that you want to do. Like, let's say, you want to learn how to rename a column in a set of data that you have. So you just search for, rename column, and then add the word pandas, just like the animal, because that's the library we're going to be using. And guaranteed, one of the top hits that you see in Google will be on Stack Overflow. And just go there and you'll find your solution. So what is Colab? So Colab is the tool that we're going to be using. It's short for collaboratory, which, if you think about the name, makes it sound kind of sciencey. And in fact, many scientists use tools like Colab as the standard way that they write their programs and they document their progress. Because Colab is much more than a coding tool. It's also a tool where you can write all your notes and insert pictures and etc. Right? It's a very nice presentation tool. So I've just highlighted a few things. Python, because it is based on Python. So that's the one language. There are other similar environments that do use other languages, but Google, when they decided to incorporate this tool, they just decided, Python is important enough. We're using Python a lot internally, so we're just going to concentrate on Python development. So if you're a Python programmer, in many cases, you could just jump over to Colab. And it runs entirely in your browser. In fact, this runs really nicely on an iPad. So if you have students that don't even have like a computer or a laptop, right, but they do have an iPad or an Android tablet, they can actually go to Colab and use it. It's fully usable. So other reasons that it's great. So we hear a lot about computational thinking. So if we look at the definition of computational thinking, some of the important things is that it allows you to break down a problem into steps and then come up with a solution that generally involves programming. And Colab is perfect for that. Second bullet, it's from Google. So that means that if you have a Google account, which most of us do, it's completely integrated. In fact, everybody knows about slides and sheets and docs inside Google Drive, But when you do, new document, new, one of the choices, if you look further down, is Colab. So it's built right in. Next bullet, it's fully integrated with GitHub, which I will talk about a little bit later on, which for me personally is a very important reason for using Colab. And then lastly, it's an adaptation of a tool called Jupyter Notebook. So Jupyter Notebook started many years ago as IPython, and then the project was what they call forked from that. It was split from that and became this Jupyter Notebook. And Colab is just another version of, or Google's version of Jupyter Notebook. So you'll hear the term notebook a lot, and that's what we're referring to, is that it's a Jupyter Notebook or Colab notebook. So a quick demo. So I'm opening this demo. This one actually is right on the Colab website. So just some of the things that I wanted to show you. I will zoom in a little bit. And Grant, if I forget to do this, can you please remind me? Yeah. So it's broken down into cells. That's the first important thing to see, right? So by its very nature, it's designed to split up a problem into different sections that you can analyze. Now, some of the things that I really like about it, each section can actually be collapsed. So you can treat a section entirely on its own, right? So you can decide what that section has to do, concentrate on that, just close the rest of the sections off. And once you've got this section working, you can close it off to concentrate on the other ones, right? That's a tool that I really like. Just helps you focus, right? On the left-hand side, this is a beautiful feature. These sections, right? It'll create this table of contents for you. So you can actually go directly to a section. Over here on the left-hand side, another thing I want to point out is a file section. So you just have to wait, right? So here's a file section. So you can actually upload files to analyze, or in fact, right here, you can connect it to your Google Drive to bring in files from your Google Drive, right? So let's just look at the different sections a little bit. So one of the things I want to show you is that the editor, the text editor, uses something called Markdown. So it's not a traditional word processor. I mean, it's kind of similar. For instance, you can have text, you can just click on the bold button, just like you would in Google Docs, for instance, but it uses Markdown, right? So I've got this one hyphen here. That means that it's a level 1 heading. If I put 2 hyphens, that would mean that it's a level 2 heading. And you'll see over on the right-hand side, the preview, that it's changed, right? If I change that back to 1, you'll see it increase in size, right? So it's a little bit different, and it's not as efficient perhaps as Google Docs, but it still works, plenty well. You'll see that we can insert pictures, which makes it really nice for note-taking. In fact, you can just copy and paste from somewhere else. So if you find an image, even on Google, right, you could just, or on a website, you could just copy it and paste it directly in. You'll see I've got a link there, so links work perfectly. If you just paste in a link without text, it's automatically recognized and converts it to a working link, which is really nice. And then an important part for people is the coding parts, right? So here I've got code inside a cell, and I can just go ahead and run it. So there's 2 different ways of running it. One is you can just click on the little run icon here, and it will run it, and it will output it right there. The second way is when you're in that cell, if you hit Shift and Enter, so this is when you sort of become a power user and you're going quickly, just Shift and Enter, and that will also run it. Okay, so here I have another cell, and in this case, I just simply have like a variable, and this is, the traditional first program that you ever write is hello world. So I have a variable called S, and I'm putting hello world in it. And traditionally what you would do in Python is you would print S, and then you run that, and then the output is going to be hello world. Now, one of the very interesting things about Jupyter Notebooks or Colab is that you don't have to put a print statement because it's designed to be interactive, right? So all I have to do now, when I go ahead and run this, it's going to work, okay? But what is very interesting is that if you actually try to print 2 things, so print one thing and then another thing below it, using that method, it only prints the last one, okay? And to me, that's just a little reminder that the idea of this is that you want to chunk up your project into very small bits, okay? So in fact, most notebooks that you find, you will not see print statements like that. You'll just see what it is you want to print, what you want to output, and it'll just be like that, okay? I think that's probably a good enough overview. You'll see, plus codes, that's how you add a code cell, plus text. Also, you can just hover over like the bottom of a cell, okay? And that's another way of just adding. Or if you're in the last one and you run that one, well, there's nothing in there, but then it would add another one automatically to the bottom. Okay. No questions coming in? No.
No, not yet.
Okay, back to here. Also, when you go to the Colab website, you will see this Welcome to Collaboratory, and I recommend that you do investigate that. Open that document and have a read through it. Okay, it's well worth your time. So let's talk about the IPO model. So typically when students start programming, we try to break the problem down for them. So in general, there's going to be an input, not always, but generally with bigger programs, right? There's going to be some sort of an input, like what is your name, right? And then the user would input their name. And then there's going to be some kind of processing generally, and then some sort of an output. Okay, and of course, not all programs are that way. Some very simple ones like Hello World is just an output, right? Whereas something like what is your name and then you print the output is only input and output. But in general, 3 stages: input, process, output. And I mention that because the data analysis process is very similar. So if we think about the input, the first thing you want to do is define the objective, right? So what is it that we're looking at? What is it that we're bringing in, right? And then, of course, as part of the input, we want to get the data. The process part involves having a quick look at the data. So this is always very important, okay? You'll never just, input it and then try to output it right away. You will want to have a look at it because often the data is corrupt, especially if you bring it from Wikipedia or from a website. There's going to be just little weird things about it that you want to have a look at, okay? And then what you'll end up doing is, cleaning the data or fixing the data or filtering the data. And then the output. So in many cases, you'll plot them. So that's what we'll be looking at a little bit today. You can export the data to a new data set, right? Or you can actually save the pictures. Now, again, think about the chunking, right? We're really trying to concentrate on breaking the problems down. So some examples of input. So this pandas library that I'm going to be showing you makes it super easy to bring data in from Google Sheets, from Excel, from tables on a website. So in fact, I have a lot of fun going to Wikipedia and finding tables and thinking, oh, that's kind of interesting. Maybe I'll do something with that. Or directly from a file, or even inside the document. You can define the data at the top of the notebook, right? And then just import it from inside the document. But I'm finding in most cases, I'm bringing the data in from outside. Process. So some of the things I'm typically doing, deleting extra rows. So there might be some rows that I just don't want. So let's get rid of those. Deleting strange characters. So as an example, on Wikipedia, there's often tables, and beside something in the table, it'll have the letter A in parentheses, which designates a footnote. So you'll get those kinds of things that come in, and when they come in, especially if it's in a number field, right? So it's like the number of people in Niagara region that have COVID today or something with the letter A beside it. When you try to process that as a number, that A there is really going to mess things up. So you have to deal with things like that. Multi-row headers, they sometimes complicate things because generally you want to deal with like a column of data. Sometimes there might be like a super header that covers a number of columns, and you have to deal with those. And missing data. So quite often you'll see this NaN, which means not a number. And when you have that, there's different things you can do. You can delete it outright, or you can interpolate between, the one above, the one below, right? And you have to make those decisions as a data scientist. What's it better to do? Delete or interpolate, or, some other method. And then output. So charts, you've seen tons of charts lately. Bar charts, you can have both vertical and horizontal, scatter charts, line, histogram, etc. And also another form of output is exporting to a new data file. So, your job might just be to clean up the data and then output a new set of data. In fact, this could be something you do for your students, where you're getting data from somewhere and it's really messy, it's got some issues in it, and you clean it up and deliver a clean copy to your students. Okay, let's work through some real examples. So the first one is from a Google Sheet. So I have opened this Colab notebook in this GitHub website. Let me just zoom in a little bit. I don't know if you can see the URL, but so this is my one of my repositories, right? And this is the notebook itself. So you can see, text, images, code, these little things here where you see the hashtags. Those are just comments. What else? There's like output, etc., right? But why I really like GitHub for coding in Colab is that you get this button right here, open in Colab. And when you do that, it will open instantly in Colab. The icon here will be a little bit different. This will tell you that you actually have it open from GitHub. Let me zoom in a little bit again. You'll see this icon right here, copy to drive. So this is super convenient because after you've done some experimenting, you can go ahead and just click on this copy to drive and you will get a copy of it. Okay, so all right, let's just continue on. So this is the objective. We're just bringing in data that looks like this. So I have a Google Sheet that has this in it already. And the very first thing we need to do, I've mentioned pandas a few times. The very first thing we need to do is bring in this pandas library. So in Python, remember we're dealing with Python here, the command to bring in the pandas library is called import. And what we do very often is, we don't want to be writing pandas all the time, right? So we come up with sort of a short form, and the convention for pandas is PD. So import pandas as PD. So that means if I want to use pandas down below, I can refer to it as PD. Okay, so I'll just go ahead and run that cell. Now we do get this scary message the first time. That's because, it's hosted from Google or by Google, and they're just warning you that, hey, it's not from them. So do you trust it? And just click on run anyway. So you'll just get that the first time. And you'll see the little icon here. It's doing this little spinny thing to let you know that it's running. And then it's done. Now, in this case, there is no output, so you don't see anything open up below. Okay, so importing a Google Sheet. So what's the secret? So you might think, can't I just take the URL of the Google Sheet and just use it directly? And that would be ideal, but you do have to make a few changes, okay? So the big change that you have to make is, if you look at the end part of the URL, so typically the last part of the address is going to look something like this. You have to replace this with this right here. And what that will do is that will convert the Google Sheet from Google Sheet format to a format called CSV. And CSV stands for comma separated values. So it's simply the numbers separated with a comma. So if we look at this, right, the way that the CSV file would be for this here, we would have X, comma, Y, 1, comma 1, 2, comma 4, etc. That's the way the data is going to be brought in if we use this export question mark format equals CSV. And of course, we need to make sure that the Google Sheet is public for the world to see, because if it's not public, Colab's not going to be able to see it. Okay. And personally, I really like this method. I think this is a great method for you to share data with your students. So what am I doing here? The only programming part is this URL equals, and then this long thing here, that's just the address of the Google Sheet. And what that's doing, it's taking the address and it's putting it in this URL variable. So I'll just go ahead and run that. And again, there's not going to be any output because it's not outputting anything. It's just doing something, right? Okay, so the next line here says, read in the data from the Google Sheet and put it in a data frame. So that's the magic of pandas, is these data frames. These data frames are very powerful and they are very fast. They are much faster than handling the data on your own. So it's highly recommended if you're doing any data analysis, use pandas, use these data frames. The convention for data frames, in most cases, you'll see them use the variable df, just short for data frame. Okay. Now the pandas library, it has a method called read CSV. And of course, our Google Sheet has been converted to a CSV file for us, right? And we just have to tell it where to get it from. So I'm just going to go ahead and run that. Okay, and it's done. And again, it's not outputting anything. It just did something, right? Now, I did mention that we need to look at the data. We need to make sure the data is okay. So some of the popular things that we do, it's very typical to actually look at the head of the data. Let's look at the top, right? So if I go ahead and run that, it gives me the top. So I can look at this and I see, aha, I've got an X column, I've got a Y column, I've got index numbers down the side, right? Now this head, we can actually change this. So if I just want to look at a couple of rows, I could do that, right? So that's typically what we would do right away, just to make sure that the columns all make sense, etc., and the data is correct. All right, and in this case, let's go ahead and I'm just going to suppress this for a second. So let's plot the data. So in this data frame, okay, there's a method called plot. And then we just need to tell it different things about the plot. So what kind of plot do we want to do? We're going to do a line plot. And we have to tell it, hey, what's the x-axis going to be? So the x-axis is going to be this column called x. And the y-axis is going to be this column called y. And it's very important that you get these exact. So, if I were doing this from scratch, you'll see me very often just coming up here and actually, grabbing it, copying it, and pasting it in. Because if you have an extra space or the case is wrong, it's not going to work. And then the Y label is going to be this, which I'll explain in just a second. And legend equals false means I don't want a legend on it. So let's go ahead and run that. And there we go. There's our plot. So it's not actually very difficult to do. Okay. Now this part with the label that I mentioned, I'll come back to. So this is using something called latex or text markup. So if you see, we've got dollar signs at the beginning and end. So that just tells Python to consider anything like this, like a caret, to be like part of an equation or like in a format that would do exactly what you want. So the output ends up being x squared. So that's kind of handy, right? Underscore would be subscript. Frac is for doing fractions, right? And it's quite complex. So, if you have to do anything more complex than that, just, have a look. All right. Okay. No questions coming in?
No, they're okay so far.
Okay. Speed must be good.
Yeah, good pace.
Okay. Next, teacher years versus grade. Okay, so this is where we had all the data coming in. Okay, and again, I'll just go ahead and open this in Colab right away. Okay, and so here's a breakdown on the side. So this is using a template that I've created that I'll be showing you later on. Because the whole process is quite overwhelming, I'll admit. It's quite overwhelming, especially in the beginning. So I have this template written, and to make it a lot simpler. So what I've done in this case, this example used my template. Okay. And again, you've got the table of contents down the side, and it's following that general input, process, output method, just broken down a little bit more, right? So the way that I propose you use the template is, certainly, this heading across the top, name it accordingly, and then just have some sort of a description in the top for, what you want to do or what the student's going to do, right? put in the objective, get the data. So then I've got sort of a standard boilerplate. So some of the things we need to do, we need to import the pandas library. We need to define the URL. We need to create the data frame, right? And depending on what it is you're doing, you might want to include some additional nodes. So again, we're going to import pandas. And we get that scary warning again. And here I've got the URL. And I'll just go ahead and run that. And in fact, it's already broken down. We've got the URL. We're reading it into a data frame. And we're going to sample. So this is a different command now. This is sample. And so instead of df.head, which we had before, we've got df.sample, which is going to just sample, in this case, 5 random lines. Okay, and if we have a look, there we go. So if you look at the index numbers, it's totally random. We've got, the 18th row, the 14th row, the 6th row, the 3rd row, the 20th. So this is kind of handy for just looking at quickly, right? So there's how many years have you been teaching? That's that column. What grade do you teach the most? That's that column. And then of course, what subject do you teach the most? Okay, and you can go ahead and run this again if you want to, just to grab, 5 different ones, right? A variation of this sample method is you can put in frac equals and then some percentage. So if you had a very large data set, you might tell it, hey, I want to look at like 1%, right? So you would put in 0.01. Okay, now let's have a look at the data. So the first few records, right? So there's that head. And again, that's traditional for, looking at the output, because that way we can confirm, yeah, those are the right headings, and yeah, looks like the right kind of data. Yeah, makes sense, right? And conventionally, we also want to look at what the column names are. And this is very handy because very often, like in this case, we can see all the data because there's only a few columns. But you may be importing data that has 50 columns and, you can't see them all, right? So by doing this df.columns, then you can see them. Now, by the way, you'll notice up here with df.head, okay, there's parentheses after it, and sometimes there isn't. And yeah, that's confusing, and you just, you kind of have to get used to that. It depends on what these are, right? So df.head is actually calling a method, and columns is actually an attribute. Another output we might want to look at, and this is very important, is the data types. So that's this D types attribute. And if I run that, so I can look at this and it says timestamp is an object. Now, notice that it didn't say date. So if I wanted to use the date as part of my data, like the x-axis of a graph, right? This data right now is not usable. I would actually have to convert it. And Pandas makes it super simple, right? How many years have you been teaching? It says int 64. So that technically that means that it's an integer and it's 64 bits long. And again, I'll come back to that. It's an integer. That means it's a number. That's good. So when we graph this, we don't have to do any conversion. If it's an object, we would have to convert it. And back to my example where we had like the letter A beside a number, if that were there, if one of those data pieces had an A beside it, that would mess it up. And then it wouldn't say int 64, it would say object. And then we clue in, we have to look at that closer, right? Okay, and this is kind of neat, a statistical summary. So what's it tell us? So the first thing is it looks at only the columns where it can do math. So you'll notice that it completely ignored the subjects column. So this is interesting. So count 23. The mean of the how many years is 16. So that's kind of interesting. Standard deviation 7. The minimum is 3 years, right? And then it's got the percentiles, and the maximum is 30. And then what grade do you teach the most? So again, there's 23 entries. If somebody left that blank, that would say 22, right? And the mean grade is grade 9. So most of your high school teachers, okay? And then the other information, right? So then we have a section here for cleaning and fixing the data. So what I started to do, because this section can be difficult, I'll be honest, can be difficult, just because no two data sets are the same. There's always something different that has to be fixed. I actually started a Colab notebook with little tips. Okay, so and as I encounter new situations, I will add to that notebook. So one of the things that I like to do, if you have these long, complex column names like this, I like to rename them. So, conveniently, there is a rename method, and I just have to tell it, columns equals, and I have to tell it what the columns are, and then I have to tell it what the new names are going to be. Right, so I'll just go ahead and run that, and then I output it right away with this columns command. And there it tells me, so we've got timestamp. So this one here, how many years, has been changed to num years. What grade do you teach the most has been changed to grade. And what subject you teach the most has been changed to subject. So the next step is filtering the data. So do we want all the data? Now this is actually a very interesting data set for doing exactly this, because we might want to look at high school versus elementary. In fact, this started with Grant and I thinking that in high school, typically teachers with more experience teach more senior grades. So that was our premise. That's what we wanted to investigate, right? So, hey, let's have a look at it, right? So what we did was we created two filters. So we have a filter called high school filter and another filter called elementary filter. And we just have to tell it that, hey, we want to look at the grade column, the grade field, and test it to make sure that it's greater than or equal to 9. And of course, for the elementary filter, we're again looking at the grade field, and we want to make sure that it's less than 9, right? So that's going to create two filters, which we are going to use later on. So let's do that. Let's apply the filters. So we're going to create a new data frame. So this is something you do quite often, right? So you don't apply the filter to the original data frame, although you can, and in many cases people do, but in our case, we actually want to create brand new data frames to use, right? So we're going to create a new data frame called sec data frame, okay? And then we run this, df, so that's the name of the data frame we're going to use, .loc for location, and then we're going to apply the filter just like this. And the same for the elementary data frame. So, where's the data that we want to look at? Well, that's in the master data frame, and there's the filter. So this is going to create two new data frames for us. And then let's check that it worked. Okay, so right now I'm just going to look at the secondary data frame. So if we look at the information, the data here, right, we could see in the grade column, everybody's secondary. If I change this to elementary and run that, and look at the grade column, we get just the elementary teachers. And of course, if I just do df, that's our original set, and I get everybody, right? And you'll notice the columns have been renamed, right? Okay, so plotting the data. So let's have a look at this. So I've got the same sort of format as before, except this is much more complex because we're not doing a simple chart anymore. Now it's a scatter chart, and we've got a whole bunch of new options. So my template actually has all the options in it. And then what you will do, anything that you don't care about, you would go ahead and just delete. Okay. So, so I've got this, we're going to look at the secondary data frame. And what do we want to do? We're going to plot it. Okay. What kind of plot? In this case, we want a scatter plot. What's the x-axis going to be? It's going to be the grade column. What's the y-axis going to be? It's going to be the number of years. Okay. Do we want to rotate the labels? So maybe you do, maybe you don't. Plot it the first time, have a look at it. What figure size do I want? So these numbers here are actually in inches, which doesn't always make sense because when you look at it on the screen, I mean, of course, it depends what monitor size you have, etc., right? And then you've got style equals. So that's the styles that you want for the lines. And then do we want a grid or not? What's the X label going to be? What's the Y label going to be? And then we've got this Y limiter, so we can actually confine this. So if I didn't want 0 to 30 on the Y-axis, I could actually change this to 0 to 10. Just look at that subset, or 20 to 30. Just look at that subset. And then lastly, the title. Okay, so as a reminder, we are looking at the secondary teachers on this one. So let's go ahead and run that. Okay, and there's our scatter plot. Now, some of the things we don't need. Okay, so for instance, the style, because there are no lines on this graph, I'm just going to eliminate that to make it simple. Okay, the Y limit, I don't really need that. I probably don't need that. So this is what you would do when you use the template. You just go through, and the things that you don't need, you would just get rid of, right? Let me rerun that to make sure I didn't mess anything up, right? And we're good. So this was secondary. Let's change this now to elementary. And you could, of course, have 3 different cells so that you don't have to keep changing the things, right? You could have an elementary cell, a secondary cell, and then one maybe for everybody. And sure enough, we get, just the elementary grades, right? And then if we want to do everybody, that's just going to be DF. And there we are. And do you want to save the plot? So this is terrific, right? So here's the code to save it. So I just go ahead and run that. Now, where did it go? Went over here on the left. Remember, we have this file section. So there's the picture right there, right? Output.ping. And you can download this. There's a little menu that appears, and you can download it, rename, delete, copy the path. So that might be interesting if you actually want to insert it directly into the notebook. Now, here's another one. One of the things about the standard pandas plotting, it's not the best tool for plotting. It's pretty good. You can do quite a bit with it, but it's not the best, right? So what if, for instance, we want to look at a trend line? So there's another library called Plotly, or more specifically Plotly Express, right? That does allow that. So I'm not going to go through the code. It's very similar here, right? We're defining the data frame, x-axis, y-axis, what the title is, and then whether or not we want a trend line. And we just, this option here, OLS, is ordinary least squares. And so the syntax, the way this is written, is a little bit different than it is above, because we're using a different library. And then I've got the save commands right here, all in the same cell. So I'll just go ahead and run this. And we were using DF here, so that's the whole data frame, the whole data set. And if we look at that, there's it's a flat line. So there's no trend.
You hover over the line, it'll show an equation. If you
Yep.
Supposed to, there you go.
Yeah. Yeah, so the slope is 0.03, 0.04. It's like 0. Yeah. So let's look at the secondary data frame. This is where we thought we would see that relationship. And in fact, it's a little bit negative. We were wrong. But this is a small data set, of course, right? Anyway, so that's an option if you do want to have a trend line in your graph. And now let's look at the columns. So this is going to be a little bit different. We have to do a little bit of processing here. Okay, so we're going to look at the whole data frame, and we want to look at the subject column. Okay, and then we have to apply this value counts method. So it's going to look at each value and just count them, and then that's what we want to plot. And so what kind of plot do we want? We want a bar H. That means it's a horizontal bar chart. If we just wanted a standard bar chart, it would just be bar. And do we want the grid? Yep, so it's true. And then what the title is. Okay, so I'll just go ahead and run that. So this is old data right now down below. I'll just run that. And that's who's in our audience. So this is actually very handy, if you're ever presenting, right? You could actually have everybody do something like this. You can make a copy of this this notebook, and then share the form, and have them, fill in the survey beforehand and then just go ahead and run this, and then we can look at that quickly and aha, we know who's in the audience. Okay. All right. How are we doing for time? 4:45. Okay, table on a website. So this is very interesting. So again, I'm opening this in GitHub. Right? And I'm going to click on Open in Colab. Because here on GitHub, it's not interactive. You know, it's just a presentation of it, right? So we have to open it in Colab to make it interactive. Okay, so this one is looking at corporate average fuel economy. So that's a standard that, you know, if you look at the average fuel economy from a manufacturer, there was a specification that they had to meet. And that was an effort to, you know, improve the mileage of cars over the years, right? So this is what the actual table looks like on Wikipedia. No, actually it wasn't Wikipedia, somewhere else. So it's going to be a very similar format. So read in the pandas library. So I'll go ahead and run that. And we get that scary warning, run anyway. There's the URL. So this was from dieselnet.com, right? So it doesn't matter that it wasn't Wikipedia. The important thing is that it's a table on a web page, because that's what this looks for, a table on a web page. So there's the URL, I'll run that. So that just sticks the address and puts it in that variable called URL, right? And then we have the same sort of format here. We're going to read in the data, right? And in this case, we're using read HTML instead of read CSV. And we're going to put that in a data frame. Sorry, this is a little bit different than a data frame right away. It's actually a list of data frames, because when you run this read HTML, it goes to the web page, it finds every single table on that web page, and it returns them in a list. So that's the first thing. Then what we have to do is we have to tell it which table on the page. So if it's the very first one, it's going to be index 0. It's all 0 based, okay? And then we put that in df, the conventional df variable name. Okay, so let's go ahead and run that. And that worked, it brought it in. Now this is one of those multi-indexes, right? If we come back to the table, we can see there's multiple rows, right? And this tends to complicate things. And sure enough, we can see that here, right? That's why it says year, cars, light trucks combined. So actually these three columns all fall under light trucks. There's some of those NANs I was talking about. Here, let me just zoom in a little bit again. It's not letting me. Okay, so looking through the data, right? We want to look for weird things. Aha, there's an A there. Might be an issue. What column is it in? Two-wheel drive. So if we're going to look at this column, that's an issue. There's some NANs, could be an issue. So you just tuck all these things away in the back of your mind, right? This last line, oh, that'll really mess things up. Okay, so let's get rid of that last line. So one of the early things that you learned about Python is something called slicing, where you take a subset of the data, right? And there's a little trick when you don't want the last line. If you just put in -1, so you see there's a colon here. So typically there's a number before the colon, but if you leave it blank, that means 0. And then a colon, and then -1, which means I want to ignore the last line of the entry. So that's basically going to get rid of it. Now in this case, I'm putting it right back in the df variable. I could spawn off a different data frame if I want to, but there's no point. I might as well just reuse that same variable, right? That same data frame variable. So I'll run that. And if we look, bang, that last line is gone. So next, let's look at the data types. So I'm just going to rerun that. Okay, they're all objects. But if we come up here, wait a second, there's numbers. We want numbers for our pretty graph, right? So, aha, that might be an issue. Let's look at the columns. Okay, and here, this tells us multi-index. So we have to pay attention to that. So let's get rid of the multi-index. So this is just a little technique that, again, Stack Overflow, that was my friend, right? How do I get rid of it? And then I learned that if you apply this dot map and then, set of quotes right together and dot join, that will actually get rid of them. So when I run this and then we look at what we get, it's kind of messy, because remember that first column, it had year and year under it. It just takes the two of them and puts them together. So we've got year, cars, light trucks combined, light trucks 2-wheel drive, because remember light trucks was one of the headers across the top, right? So it just combined them all, kind of messy. So let's rename them right away. So we've already done that, and it's using the exact same format. So if I run that now and look at the new column names, I get year, I get, CAFE, CAFE, miles per gallon, etc. So they're all nicely cleaned up. Now we need to convert all those objects to numbers. And again, Pandas has beautiful methods built into it. So there's one called toNumeric, which will take the data and convert it to numbers. So which columns do we want to do? I want to do the year, and I want to do the CAFE miles per gallon, right? So this will look a little bit different. Before I was just doing DF on its own. Now I'm doing DF year. So I'm actually picking the year column. So whatever I do on the right-hand side, it's going to do that process, whatever we're telling it to do, and stick it back in the year column. Okay, so it's just going to run this, toNumeric. Sorry about that pop-up all the time. That's actually a bit of a nuisance when you're using it. It's going to run this toNumeric on that column and stick it back in here. Likewise with this column here, it's going to convert it to numbers and stick it back in. So let's run that and confirm that it worked. And it did. So here you'll see int 64. So they were all integers, so it made it an integer field. And this column, there were some real numbers in there, so it converted it to floating point. And we didn't do anything with the rest of them because for this particular application, we don't care about them. Okay, so let's plot. So again, it's very similar. What is it we want to plot? The data frame. We're running the plot method. What kind do we want? We want a line. And then we're defining what our x-axis and our y-axis is going to be. And there we go. Okay. Now we've got this legend here. So remember there was a legend option. So we could say legend equals false. That would turn that on. If we wanted the grid, we would say grid equals true, right? So we would apply those little things. 5-2. How am I doing, Grant?
Yeah, we're almost 5.
Okay, adding a new column using math. So I figured there would be quite a few math teachers in the audience, so this will be very useful. So again, I'm opening it in GitHub, but I'm going to click on Open in Colab so that we can interact with it. I'll just go ahead and get rid of this on the left-hand side. So what is the objective? So the objective, oops, I didn't mean to open that. The objective is to add a volume column. So when we look at the data that's coming in, we're just going to have 3 dimensions. We have width, height, and depth, but we want to calculate volume and actually add that to the data set. So what do we have to do? We have to import the pandas library. Just like always, we need to define the source file, just like always, unless the data is internal, and we need to create the data frame, just like always. So import pandas as PD, yep, that's the same, and import random. Well, that's interesting. What I'm going to do for the data in this case is actually create random data. And we get that scary warning again. Okay, and it runs, and there's no output. Okay, so here I have a function that basically creates the random numbers. Okay, and because I have to do the same thing 3 times, once for the width, once for the height, once for the depth, instead of writing this long piece here, 3 times, I just created this function, and I just run it from down here. So that's a little bit advanced perhaps for this session, so I won't walk you through that. So I do have to run it just so that the notebook knows that it exists. If I did not run this function, then when I try to call that function from here, it would say, hey, I don't know what that is, because we didn't run it yet. We didn't let the notebook know that it exists. So what's happening here? So we've got 3 variables. Okay, each of these is going to be a list. And all we're doing is we're running this function that I wrote called create 5 random integers, right? So up here, it's going to create 5 numbers and return them to here. And then I'm putting all those in a dictionary. So this is a little bit difficult in the beginning, but this is the way that Pandas wants to see internal data. It wants to input it from a dictionary, because the nice thing is when you do it this way, it automatically knows what the headings are going to be, right? And then this format is a little bit different. This time we've got pd.dataframe as opposed to read HTML or read CSV. It's just we're creating a data frame directly from this box dictionary, from this set of data right here. Okay. And then here, of course, we're just going to output it. So let's run that. And there's the random data that we get. So if you look at the first line, we've got 337. If I run it again, I've got 554. So it's going to be random every single time. And let's have a quick look at the data. So this is the process you would go through, right? So let's run that. All right, so we've got a width column, we've got a height column, we've got a depth column. So yeah, makes sense, right? Those are the decisions. That's the thought process you would go through. The data types, we would run that. And if we look at them, they're all integers, int 64, int 64. So that's good. They're all numbers. Describe. Let's look at it again. Again, they're numbers, so let's see, right? And if we look through those details, all make sense. There's 5 of them. What's the mean of them? What's standard deviation, etc. And do we need to do any cleaning? So this is the section where I propose you do things like delete columns or add columns. It's in the clean, fix, filter the data section, right? So it's actually very simple. The syntax to look at a particular column is just that, the name of the data frame, and then in brackets, you put the name of the column. And if you see here, we're doing some simple math. We're just multiplying the depth times the height times the width. And we're putting that in a new column called volume. So it's actually very simple to do. I mean, if it wasn't data frames, we would simply say volume equals depth times height times width, wouldn't we? So this is just, for each data frame, multiply them and put them in a new data frame. Or a new column, I should say, within the data frame. And when we output that, there we get it. There's our new column right there. And if we check the math, right, 5 times 5 times 4 equals 100, works out. Okay, so this might be very interesting for you to do. And again, because I thought there would be math teachers in the audience, this might be very useful for you.
We're at 5 now.
Okay. So time is good?
Yep, 5 o'clock.
Okay. Okay, this one is going to be a bar chart looking at the mass of planets. And again, I'm going to open it in Colab so we can interact with it. I'm not worried about the table of contents on the left, so I'm just going to close this off. Okay. Now this is a later version of the template. So this notebook is based on the template found here. And so that way you can always go back to the original template, which I will show you. What's the objective? To produce a bar chart of the mass of the planets. And there's the data source. And again, this sort of recipe, we need to import pandas, define the URL, right? So let's run that. Scary warning. So now pandas is imported. And again, we're defining the URL. So it's the planet page on Wikipedia. And here's this list of tables data frame format that I was talking about. So we're using read HTML. So again, it's going to go to that page, right? It's going to go to that page and it's going to find every single table on that page and return them as a list of data frames. And then I've already worked out that it's the 8th table, which is why I have the number 7 in there. Remember, it was 0 based. So 0 would be the first, 1 would be the second, etc. Right? So let's go ahead and run that. And there's the table, and just looking at it quickly, yep, makes sense. Now if I change this to like 6 and run it, that's interesting, but that's not the one I want, right? So this is the process you would go through. You would think that often you could just go to the page, and count like, oh, there's the first table, there's the second table, etc. But very often there's tables that you don't realize they're tables. Like sometimes when they created the web page, they put in tables just to clean up formatting, so you don't always realize they're tables. Okay, so what are some weird things we have to look at here? Well, Earth has this little A beside it, so we know that's a hiccup. And we've got this last line that's a hiccup. So there's a few things we need to deal with, right? And I'm interested in the mass column. So everything else looks okay. All right. So quick look at the data. And again, same sort of thing. Let's look at the first few rows just to give us that warm, fuzzy feeling that everything's okay. Let's look at the columns. Let's look at the data types. And if we look here, okay, so we want the mass column. It's an object, not good. So we know we have to deal with it. And we can do a statistical summary. Now you would not run all of these all the time. Like right now, I might not care about the statistical summary. So that line of the template, just delete. Now, what do we want to do if we just want to look at one column? Well, we've actually looked at that quite a bit, right? You just put in the name of the column in brackets. Right, so we can just concentrate on that one column. If we want to do another one, so I could grab the name of that, and again, I'm just going to highlight it like that, and then paste it in, because you do have to get this exact. Okay. All right, looking at multiple columns. So if you want to look at multiple columns, then you would have to put them in a list. So you have to put an additional set of brackets. Okay. And then you put the two different column names inside that list. All right, you want to look at unique values? Could be interesting. So the rings column has no's in it and it has yeses in it. And this one other long one. So that's, from that last row, that kind of messes things up. So then we move on to cleaning, fixing, filtering the data. So we know we have to get rid of that last row. Remember that last row right here? So we can use that slicing method that we used earlier on, right? And you could count the rows and or do the -1 like I did before. Okay, so I go ahead and run that, right? And that last row is gone. And Earth, so remember Earth had that name, that A beside it. We want to rename that. So here we have this loc. So where's the number 2 come from? The number 2 comes from here. That's the index number of that line. And which column do I want? Well, I want the name column, right? And I want that to equal Earth. So let's run that. And we get this scary message here, but the Earth column has been changed. So let's look at the head. Okay, and we're confirming here, Earth has been renamed. Okay, and remember the mass column was an object, so we have to convert that to numeric. And so we've seen that before. That's simply that to numeric. And there are the numbers, and it confirms for us that it's floating point, 64-bit. And then let's plot. So by the way, I haven't talked about this, all the different ways that we can plot. So bar charts, histogram, box, density plots, area, scatter, hexagonal, bin plots, pie plots, and there are more if you look up the documentation. So we're using the data frame. We're going to plot it. What kind of plot do we want? Well, in this case, I've got pie plot. I'm looking at the name. I'm using the mass column. I want to rotate the labels 20 degrees, and you'll see later on why I did that. There's the figure size I want, so it's going to be 10 inches by 5 inches. I want the grid to be on. I want the legend to be on. I've got log y. Why did I do logarithmic? Oh, probably, let's just comment that out. So here's a handy technique. If you hold down control slash, it will comment out that line. Okay, You could, of course, manually do it just by putting # in front of it, right? But I tend to just use the keyboard because it's much faster. And then what do we want the labels to be? Well, there is no X label on this, so let's just get rid of it. And the Y label and the title, so let's run this. No, that's not very useful. So this isn't really how I want to look at that, so let's just change this to a bar chart. Aha. So this is why I want logarithmic.
Jupyter's too big. I think that's a.
Jupyter's skewing our graph.
Everything else looks small compared to Jupyter.
Right.
Yeah.
So now it kind of makes sense, but you just have to remind people that it's logarithmic. Okay. So this one's kind of interesting because there were more things that we had to fix, and that's often typical when you're pulling in data from somewhere else that you have no control over. Yeah, I see a comment. Making of graphs in Google Sheets is a nuisance. Yes, it is. And I think once you get used to this, especially if you use the template, you'll probably like it better. So what I would recommend, if you have your data in Google Sheets already, just make it public so it's accessible to here, and then use my template to graph the data. Okay, so where do we get the data from? So I recommend, honestly, read the data from somewhere online. Yes, Colab has a file section, but if you bring in files, if the runtime processor stops, any data files that you have in there disappear, because Google is giving this out for free. So they don't want big data files taking up a lot of space, right? So I honestly recommend read them from somewhere else. I use a GitHub repository. I also use a tool called Gist, which also belongs to GitHub, and it's very, very convenient to use. And I recommend that you investigate that. But Google Sheets is also a great source for your data for Colab, right? And it's much easier that way because you can put it online and teach your students the simple way to import that data, and then you don't have to worry about getting the data to them, right? They don't have to copy the data from somewhere else and drag and drop it in, right? They just read it from one place. Okay, so I'll show you this resource that I developed. I'm not going to go through it in detail because there's a lot of things here, and I do recommend that you open this in Colab as opposed to just on GitHub, because then you get this table of contents on the left hand side. So there's different sections. There's a section for deleting rows, and then there's two different methods. So deleting rows at the beginning or end, rows in the middle, replacing specific data, and again, a couple different examples, converting to dates. So remember I said it was pretty simple to convert data to dates. And that would be if you want, for instance, date to be across the x-axis. That's a good example. Deleting columns, there's a couple examples. Editing headings, so the different kinds of things you might want to do. Replacing characters in the headings, changing the case of headings, renaming one heading, renaming multiple headings, right? So I've got all these examples. And again, this is going to be a live document. So as I encounter new situations, I will add them to here. So here's the template. This also is a live document. I'll just go ahead and open it in Colab. Actually, I'd better not do that in case I change things. So here it is in GitHub again, and open in Colab. Now this is a copy of the template. I said I don't want to open it in Colab because I might change things, right? If we look at things here, I've got this little GitHub icon in the top left, which tells me that it's not my master one, right? And also it says copy to drive. That's another clue to me that I'm not editing my original. So this is a blank template that you would use yourself or you would share with students, right? And it's completely blank. So where it says title, obviously, you put in the title. And I say here, use this template as a starting point. So this has a lot more in it than you would need, for sure. So the stuff that you don't need, just delete it. Just get rid of it. Okay, likewise with sections, right? If you want to, if there's sections like the clean, fix the data section, if you don't have to clean or fix the data, delete that section, get rid of it. So I recommend here, change the title at the top and any text under the heading to make your code and comments relevant. So this is like the big picture. What is it you want to do? And then the objective. So what is it you want to analyze? Where's the data coming from? What output do you want? So this is ideal for you to share with students, because you might tell them, like, let's say you're doing, a planet section. You want them to plot the mass of all the planets, right? You could define all that in the objective. I want a bar chart of all the masses of the planets. It's coming from the Wikipedia page, and well, that covers what you want to analyze. Then get the data. So again, this is the whole process, right? So you don't have to keep all this. Once you've done it, you could actually delete those comments, right? And then it's broken down into, so again, this is, I'm covering everything, right? So the get the data section, I've got two here, from a website or from within the notebook. So what you would do is, hang on, I just have to get rid of all the people there. So from within the notebook, if we don't want that section, I can collapse it down and I can just delete it. Okay, and then it's gone. I won't do that just yet. Yeah, no, I can do that because I'm not going to go through it in detail. Then we've got quick look at the data. So I cover all the bases here. If we want to look at the top, if we want to look at the bottom, if we want to look at just a sample, if we want to look at the columns, if we want to look at the data types, if we want to do that statistical summary, right? I've got them all here. An example of looking at one column, an example of looking at, unique values. So it's probably the most common things you would want to do the first time you look at the data, just to make sure that it's okay, right? And if there's something you don't care about, like if it's not statistical, this statistical summary one right here, just delete it. Okay. Cleaning and fixing the data. So I've got an example here of if you want to rename the columns. And again, if you're not renaming any columns, gone, right? And then here I've got a link to that fix it notebook, right? Which might help you out. Filtering, I've got an example here of how to filter the data. And again, if you don't want to filter it, get rid of it. Get rid of the whole section. And then a very generic plotting routine, right, with all the options. And if it's things like a bar chart, right, and you don't have to worry about the style of the line, then delete it or comment it out. Okay, or whatever. I've got some other ones we haven't seen, X limit and Y limit. Oh, I think we did see that. And that lets you restrict the X-axis or the Y-axis and everything else we've seen, right? Defining the X-axis, the Y-axis. There's a little note here. If you're plotting more than one column, use a list, right? So a list would mean that you simply take that, put it in brackets, okay? And then separate the two items, okay, with a comma, all right? And then if you want to save the plot, there's the code for that. And then down at the bottom, I've got the original of this template can be found on Google Colab here. So if you ever want to go back to it. And as this changes, for sure, my copy in Colab is, it's always going to be the original, right? The most current one. The one on GitHub, I can't guarantee that it will be the most current forever. Probably for the next 6 months I will, but after that, I may have moved on to a different repository where I'm putting this stuff. I'm not sure, but for sure, if you go back to the original, you'll find it there. Now I'm getting this warning all the time because I've made changes, and generally what you would do at this stage is you would rename it. Actually, no, you have to copy it to Drive first, and then you would rename it, right? And so it senses that I've made changes. So, when I do try to close it, it's just warning me like, hey, are you sure?
We're at quarter after, so yeah, that's.
Yep, I think we're in good shape. Okay, so let's have a look at the repository. So for many of you, I'm sure this is going to be the first time you've looked at GitHub. some of the, well, big picture of GitHub, it is the place where people collaborate on writing code. So any of the big open source projects that you hear about, like Firefox, it's not called Firefox now. What is it now?
I don't know. I thought it was.
Oh, okay. They keep changing the name on me over the years. Anyway, there's a good chance that the source files for that live in GitHub. There are other repository sites, but GitHub, without a doubt, is the most popular. It used to be quite expensive to have private repositories, but Microsoft bought it, and they promised that they would keep it independent from Microsoft. So, for instance, your Microsoft account will not log you into here. You have to have a local GitHub account. And it allows you to put files in here. It doesn't just have to be text files. I have a repository that is curriculum documents from different provinces and some states. And they're like Adobe Acrobat files, so it can be, non-text files. But ideally, GitHub's kind of designed for files that it can read and easily compare, right? So it does things like versioning, where you can look at different versions of a document. What did it look like yesterday? And if you ever want to go back to the previous version, you can do that, right? So here on the front page, you can see a number of documents. So all the demos that I did are right here. Okay, here's the template right here. This .git ignore, that's a bit of a geeky thing. If you look in that file, that's just telling a program that I use when it uploads what files to ignore. And then I've got a data files folder. So you could actually put data files right in here and then pull them in, right? Now, the thing to observe when you do that is, if we look here, I've got this bad cafe data CSV, right? If you shared this with your students, right? If we were just to grab the address at the top, right? Grab the address at the top and share that with the students, it would not work. Because what you actually want to give them, if you look down here, there's this raw button, and you click on that, that's the raw file right there. A bit hard to see maybe, right? That's the raw file. So it would be that address that you would share with your students. Okay. Okay, just coming back to here. Now, there is a file called readme.markdown. So if you start using GitHub yourself, if you create a file called readme.markdown, that is the file that is right here. And actually I have quite a bit of useful information for you here. So a bit of an introduction that you can read, right? It's just a working table of contents. So if you click on this, it'll bring you down to that section. So the basic process we talked about, data sources. So where do you get your data from, right? Kaggle is a huge data site. It's amazing. New York Times, they have open data. COVID data by country, our world in data. So that was passed to me on Twitter, World Bank. And here's an article that talks about the best open sites. Within Ontario, within Canada, Canada has an open data site. Ontario has an open data site. Your county will probably have an open data site. Like I'm down in Niagara Falls. Niagara has an open data site. In fact, I went to it, and you find the most bizarre things. I found one, and it was a count of all the trees in St. Catharines. Like bizarre. They actually did an inventory of how many trees there were and what kinds of trees they were, right? So you never know what you find. And I've got a section here on Colab resources. So this Welcome to Collaboratory, that was the document that I showed you earlier. Some FAQs. This is handy, open in Colab Chrome extension. So I have, well, I can't see it because of a menu from Zoom, but up in the right-hand corner up here, I've got a little icon to let me open Colab notebooks that are in GitHub, right? So if somebody accidentally, actually, let me back up a little bit. If somebody posts a Jupyter notebook that didn't come from Colab, but from somewhere else, if they put that in GitHub, you could use that little Chrome extension to open that notebook. So other than not coming from Colab, everything's the same. Doesn't matter where that notebook came from. If you want to do a lot of text processing, here's a Markdown guide that'll be quite useful, right? And then I put together a video a few days ago how to integrate Google Drive into Colab. And so here's the blog post I did on it and the video I made. And then some other useful data science resources. Indexing and slicing, if you want to learn more about that, that's a useful one. List comprehension. So that's a kind of a, I won't say more advanced, it's actually not that difficult, but when you first see it, it looks intimidating. But I recommend if you're creating your own data sets, like of random numbers or whatever, have a look at that. Here's two very useful cheat sheets. Very useful. So, you can open those in another tab and refer to them, right? Some plotting resources. So remember the mathematical expressions I was showing you, that text or latex, that's right there. The different line styles. And then all the links that were in the presentation are all here, including a couple that I'll get to. Yep, 9 minutes, I've still got time. And if you have suggestions or issues, okay, then let me know here. So if you actually click on that, that will open right here. So this is kind of nice. This is one of the ways that it's a collaborative project area, right? You can open an issue. So if you spot a bug, you open an issue, and then the person that owns the repository, they get notified about it. And you can actually have a conversation online, right, about what the issue is as you're trying to fix it. So it's very handy for that. If you want to download the repository for yourself, right, there's a download link here, and you've got different options. You can download a zip of it and just extract it on your computer. There's the address of it, or GitHub Desktop. So that's a utility that I use for uploading and downloading any changes that I made. And I love it. That's what makes GitHub so easy to use, is this GitHub Desktop. Okay, what else do I want to show you here? That's probably about it. There's lots of course, more advanced features, but I've covered the basics here enough to get you working. Question, will you recommend we clone it? Do you mean the repository? I don't think it's necessary. If you just have access to the link, then you can just go ahead and access each resource independently. Plus, if you clone it, then you won't have the most current version.
I think we'll have to skip this part and just go to the Colab
Okay.
and then have questions.
Okay. All right. So I do have some slides here I'm just going to skip over, but if you are interested in pursuing GitHub more, have a look at these, please. I do have some, geeky definitions from online, but there's my definition. It's a good place to share your data files and Colab templates from. And then there's just, I was going to explain that a little bit differently. This is just a screenshot of GitHub Desktop, and it makes it really easy to track changes. So here, this blue button that says push origin, that means that I've made a change on my local computer and it has to be pushed up. And then, there's a button here, open in Visual Studio Code. So that lets me open it in my editor, show in Finder, or on a PC, it would say show in Explorer, I guess. And then view on GitHub, which is often handy if you just want to have a look online to make sure everything's working okay. There's the Chrome extension, right? So I recommend if you're going to start playing with Jupyter Notebooks, go ahead and install it. Okay, so we do want to give a shout out to a website called Callisto. So Callisto is a Canadian Jupyter Notebook hosting service. And their primary emphasis, as far as I can tell, is to education. So if you go there, they've got many lesson plans by subject area. So it's worth pursuing, right? Yeah, so one of the things that sort of deterred me from using it more is that it doesn't integrate with Google. So if you want to access your Google Drive from it or open up like a version of it in your Google Drive, you can't, and it doesn't integrate with GitHub. And especially that GitHub part, that was really important for me, which is why I really like Colab instead. And it's being used by this upcoming hackathon for teachers. I shouldn't say upcoming because it's actually in progress. It's a 3-month project that Andrew McDonald is working on. And I believe I have it open already. So here's the website. I recommend, have a look at his lessons that he's got here. So he's already posted a few lessons. So if we go into rock, paper, scissors, and data science, right? He's got a video and he walks you through, the tutorial, and then there's also a lesson plan that goes with it. So I highly recommend check it out, and you can sign up and follow along. And then lastly, I just want to give a plug for the ACE mail list. So ACE in the beginning just concentrated on high school computer studies teachers. But now, of course, coding is happening more and more in the elementary panel. So we're concentrating on that as well. So for instance, every year at our annual conference, we always have an elementary stream as well. So if you're interested, please join our mail list. It's a very, very active mail list. It's truly wonderful. We share like crazy on there. I'll just leave that there for a second if you want to write that down.
It's free to join too.
Yeah.
There's no fee for the subject association.
Yeah. Yeah. Once you join the mail list, you are a member. That's the way we run it. Okay. Questions?
This is like a fire hose probably for a lot of people, but is there a simple way to convert a markdown file into a Colab file?
Once you have a markdown file, as soon as you paste it into a text field, it automatically converts. Yeah, so if you have markdown from somewhere else, it'll convert, no problems.
She's mentioning about having code cells, though. I don't know if that.
You would have to break those down. So if you just have it like as a text file, for instance, one long text file with code and markdown in it, you would have to paste each section. So the markdown section into its own text cell and the code section into its own, coding cell. Yeah, and then there's a request to drop in the. I'll just put that up on the screen.
Yeah, on the ace.net website, if on the main page down at the bottom, you'll see the link as well if you don't have the mail list there. But
yeah, lots to experiment with, that's for sure. I have been experimenting with this like crazy. It's fun, and it's sometimes frustrating because, like I said, it seems like no two data sets are the same. There's always one little different thing, right? So, just from watching other videos that people have done, a big part of it is just, poking through the data to find out like, hey, why isn't it converting to a number, right? That sort of thing. So yeah, it's cool.
One thing to keep in mind is just that for any of the math teachers, there's quite a few sites like and tools like Desmos. They're great for analyzing functions and continuous data sets. But when you get into like the MDM or any kind of data analysis and science or whatever, you don't have an equation to work with. You're trying to derive the equation or look at correlations or out of raw data. So there really is no tool other than a spreadsheet or something like this. And you can see how this is more powerful, but it does require a bit of coding knowledge. And this is part of the, integration of coding into other subject areas. It's going to slowly, not that everybody's going to be teaching computer science. That's really, the elective courses, that's our focus, but a little bit of coding knowledge is integrated into pretty much any post-secondary program these days. So this is an opportunity, and Python is a general purpose language that you can see we didn't, try to teach you the Python programming language, just enough to get the job done. That's kind of the idea.
And the truth is 95% of what I showed you is pandas stuff. It's not Python at all. I mean, I did have, like a loop in there and one function, but other than that, it was all pandas stuff, right? So there's actually truly very little Python specific stuff. And
nobody would ever memorize this in front,
no.
It's stuff you just look up. It's the Google world, right?
Yeah.
So
yeah.
That's that's very normal. Computer scientists are just good at finding stuff.
Yeah. You can't see this right now, but I have like a laminated cheat sheet that I keep right beside me. Grant actually made a joke about that, but I'm looking at it all the time.
Retired teachers with laminators.
yeah, that's right. Funny. Eh?
Any other questions? Thank you. So just the database software. Database is totally, it's kind of database-ish. That gets into a whole other kind of thing, but data frame is like a table in a, or a matrix. So same idea.
Yeah. And many people are switching away from dedicated databases to a tool like this. Like you essentially write your database software in Jupyter Notebook, right? And that becomes your database software. So then if you ever have to tweak it, it's quite simple.
And we kind of got we got hooked on exploring this more because there was an actual an online, not competition, but a free kind of learning tool by Lighthouse Labs. Last year it was about JavaScript, and this year it was about data science with pandas and Python. So we had a teacher team of about, I don't know, about 8 teachers, and every day we'd have a new challenge. So that's how we kind of started exploring. That's how we came up with the idea of sharing what we've kind of explored. So that's how you learn, is just trying something new. Any other remaining questions, or?
5:31, not bad.
Well, thanks for coming. And I don't know if Michelle, you had something to wrap up, or? Thanks, Peter. It was great.
Thank you.
Yes, I will jump back in for a few seconds. So thank you, Peter and Grant, for this really a fantastic webinar. I must say it was a very high level presentation, quite complex and a bit overwhelming, at least for someone like me, I must say, because I have no coding experience. I was a photography teacher, so obviously for me it was a lot of Chinese, but very, very high level, I must say. Also great teamwork, because Grant did a lot of work in the background, answering all the questions that were coming into the chat box. So that was really excellent. And also thanks, Peter, for the presentation, and also preparing all the references and the website, the tools, all the links that you have. And I just want to tell everyone before you guys leave that we will send you an email tomorrow with all these links and all this information, so you don't have to worry. And I want to, of course, thank you all for your participation. If you can give me another few minutes, I'm just going to quickly share my screen again with you guys to tell you what's happening with OTF. So you will get the email tomorrow with all the links, as we said. There's also a little questionnaire. If you have a few minutes, we like you to answer this questionnaire. It helps us with refining and improving our OTF Connects webinars. And also, I just want to let you know we are halfway in our series of 6 webinars. We have 3 more to come, and they are all on Thursdays afternoon. So try to keep your Thursdays open. On May 13 and May 20, we have student-centered K8 culturally responsive coding experience. The facilitators are Melanie Mulcaster, Amanda Williams-Yeager, and Michelle Peter Adlams. And then on May 27, we have integrating Minecraft and Make Code Code Builder into your math program. And the facilitator is Andy Forgrave. So I really hope that we will see you for these 3 upcoming webinars and the next 3-4 weeks. And I want to thank you all once again for your participation. And of course, I want to thank Peter and Grant for preparing all of this for us. And I look forward to seeing you again next week. So thank you
Thanks so much, everyone.
Yep. Thanks very much.
See you all.
I'm going to stop the recording.
Have a great night.
Thanks so much.
Thank you.
Yeah. Bye-bye.